Okay, we are going to talk about equations of circles. This was actually in an earlier chapter that we didn't cover at that time, but we have time now to go back and hit section 17.1, which is on equations of circles. So first we're going to see if we can derive an equation for a circle that's centered at 0, 0 with a radius of 5. So go ahead and draw yourself some x and y axes. And our center is going to be at 0, 0. And then if we have a circle with radius 5, we would go 5 to the, we'd go 5 in every direction. So 1, 2, 3, 4, 5. I know my circle is going to go 5 to the right, 5 up, 5 to the left, and 5 down. Okay, so do your best to try to draw a circle that goes through those 4 points. Okay, now in your groups, go ahead and see if you can find any points that have integer coordinates that you know for sure would be on the circle, or it looks like, maybe it looks like they're on the circle. So, for example, this point right here is 1, 0. Okay, so I write down the coordinates of that point. So list as many coordinates as you can for the points that are on the axes, but see if you can also find some points that are not on the axes. So you're listing as many coordinates as you can for points that are definitely on the circle. Okay, so again, that first point should have been 5, 0, not 1, 0 like I had originally listed. And then, let's see, Olivia, can you give me another point? Negative 5, 0 would be over here. Negative 5, 0 works. Okay. Santi, can you give me another one?
I got 4, 2.
4, 2. So 4, 1, 2, 3, 4, and up 2. So mine doesn't look like it goes through 4, 2, but I just freehanded my circle, so maybe it actually does curve through that point. So how could we tell whether or not 4, 2 actually is on that circle? Anyone know a way we can mathematically tell, Andy?
Could you do like the distance formula to find if it's 5 or 8?
Yeah, you could do the distance formula or just the Pythagorean Theorem. Same thing, because the distance formula really is the Pythagorean Theorem. If this is 4 and this is 2, what would our hypotenuse be? If we call this c, then we'd have c squared equals 4 squared plus 2 squared. C squared equals 16 plus 4. So c would be the square root of 20. And the square root of 20 is 4.47. So it's close to 5, but it's not exactly 5. So that point, even though it might look on your drawing like it's on the edge of the circle, it's actually not. But that's how, this is the, how we can tell. So I'm glad that Santi picked that point for us to investigate, because now we have a method that we can use for checking other points to see if they're on there. So 4, 2 is close, but not quite on the edge of the circle. Okay? So that was good that we were able to look into that. So 4, 2 did not work. Okay? Let's see. Savina, did you find another point? 0, negative 5 down here? 0, negative 5 is definitely on the edge of the circle. Sarah, you have another one?
3, negative 4.
3, 1, 2, 3, negative 4, 1, 2, 3, 4. Okay. Again, that looks like it's close, but my circle was just hand-drawn, so it might be on the circle, it might not be. So let's check it the same way we checked Santi's point. If this is 3 and this is 4, what would the hypotenuse be? 5. It's a 3, 4, 5 triangle. Okay, or you can use the Pythagorean theorem. 3 squared is 9, 4 squared is 16. 3 squared plus 4 squared does equal 5 squared, because that's 9 plus 16 is 25. You get 25 equals 25. Okay, so Sarah found a good point that's not at one of the axes, but is on the circle. So my hand-drawn circle should go through that point, so I'm going to correct that a little bit. So 3, -4 is a point on the circle, and we can tell that because it fits the Pythagorean theorem and gives us a hypotenuse of 5. Okay? Let's see. Ellie, you have another one?
0, 5.
0, 5. It's up here. Good. And James, do you have another one?
I have -4, 3.
-4, 1, 2, 3, 4, 1, 2, 3. Okay, again, my circle doesn't actually go through that point, but it comes close enough, and we can see that that creates another 3, 4, 5 triangle, so that point would work. So that's -4, +3. Nice job. Okay, Christopher, you have another one? -4, -3 would be down here. My circle should go through that point because that is also a 3, 4, 5 triangle. Okay, good. So we have several that we could get. We could do -3, +4. So here's another one up here, -3, +4. So we could go around and fill in many points. We have +4, +3 would be over here. +4, +3. Okay, as long as our coordinates are 3 and 4 or 4 and 3, positive or negative, then we're going to get a 3, 4, 5 triangle, which makes a hypotenuse of 5. Okay, so those are several points that are on the edge of the circle. But there are many more points that might not have integer coordinates that are also on the edge of the circle. And we want to be able to write an equation that will help us find the coordinates of those points. Okay, so what I'm going to do now is pick a point and just call it xy. So I have a point on the edge of my circle. We're going to name it xy. In fact, I'm going to do it in red so we can distinguish it from the other points that are there. Okay, so we have this random point, and we're going to call it xy. Okay, now the way we tested the other points to see if they were on the circle was by using the Pythagorean theorem. So if this distance is x and this distance is y, and we know our hypotenuse is 5, what equation could we write? Using that right triangle. Discuss in your group, see if you can write down an equation that has an x and a y in it that would show the relationship for any point that's on that circle. Zarin, what'd you get?
We're not really sure.
Okay, apply the Pythagorean theorem to that red triangle that I have drawn.
X squared plus y squared is equal to 5.
5 squared. Good. So x squared plus y squared is equal to 25. Okay? So that is actually the equation that represents every single point on that circle. So if I wanted to know, for example, what is this point right here? Okay? It's got an x-coordinate of -1. What is the y-coordinate? It doesn't look like it's quite 5, but it's close to 5. So if I wanted to know the coordinate of that point, the x-coordinate is -1. If I want to find the y-coordinate, I could just plug in -1 for x. And then I'd have 1 plus y squared equals 25. So y squared equals 24. And then y would be the square root of 24, which is about 4.9. And so this point is approximately -1, 4.9. Or if I wanted to write it in exact format, I could actually say it's -1 square root of 24. And that would be exact. So that this equation that I have in the box here represents every possible point that we could pick on that circle. Okay, so that is the equation of the circle. If I go into Desmos, and I type in x squared plus y squared equals 25, look at what it graphs. It graphs that circle. Circle with a center at 0, 0 and a radius of 5. Okay, so now I'd like you to try this one in your group's example 2. It's a very similar problem, but now we're just saying the radius is r. So draw yourself a sketch and see if you can write an equation, kind of like the one we put in the box up here, but we're writing an equation for a circle centered at 0, 0 that has a radius of r. Joan, did you come up with an equation?
X squared plus y squared plus r squared.
Perfect. So it's the same kind of situation as what we had up above, but now we're just saying the radius is any number r. And if we draw the right triangle for any point on the circle, xy, it has to fit the Pythagorean theorem, so x squared plus y squared has to equal r squared. So that represents the equation of any circle centered at the origin with a radius of r. And then I can even go back into Desmos and change this to r squared and add a slider for r. And so now as I change r, we see the circle still has the same center, but as I slide the slider, the radius is changing. Okay, so if I make the radius, if I make r equal to 6, we have a circle with a radius of 6. If I make r equal to 10, we have a circle with a radius of 10. Okay, so that is an equation that we can use to represent any circle with a radius of r. Okay, now I'd like you to take this one step further and draw a circle. Just do a hand-drawn sketch of any circle centered at 3, 1 that has a radius of 4, and see if you can come up with the equation of that circle. But go back to what we did on the first problem and go through the steps and see if you can come up with an equation using the distance formula or the Pythagorean theorem.
This is a whole number, like what do I put that down as a whole number, or does it have to have like a radical next to it?
Oh, it doesn't have to have a radical. It can be a whole number. Okay, so I'm going to go ahead and I marked my radius or my center at 3, 1, and then radius 4 means I'm going to go 4 in each direction. So I'm just going to roughly draw a circle that would go through those points. Okay, and then if we pick any random point on the edge of the circle and call it xy, we can use the Pythagorean theorem like we did before, but the problem is before this was x and this was y. But that's not the case anymore, because what does x mean when we plot a point on a graph? If this had, like, for example, this point has the coordinates 3, 8. Okay? What do the 3 and the 8 really mean? How do we get to 3, 8? That means the horizontal distance is 3 and the vertical distance is 8 from the axes. Okay? So when we name the coordinates of a point, we're saying how far those points are, or how far the point is from the x and the y axis. And so this distance is x, and this distance is y. So that's what x and y represent on any graph, is how far away they are from the x and the y axis. Okay? Now we know that this distance is 3, and this distance is 1. Okay? So the question is, how long is that, where the question mark is, can we write an expression for that distance, and then can we write an expression for that distance? Okay? So go ahead and discuss that in your group. See if you can write an algebraic expression to fill in each of those question marks. It's going to be a different expression for each one, but see if you can replace those question marks with mathematical expressions. So did anyone come up with an expression for this question mark for the horizontal segment? So take a look up here, watch. If this is x and this is 3, what's left? If this is x and we take off 3, what's left over? X, take away 3. So think about it if it was numbers. If we had a segment that was 10 and this was 4, how long would that be? 6. You get that by subtracting, right? You take the long length, 10, subtract 4, that leaves you with 6. We can do the same thing here. If this is x and this is 3, Giancarlo, what would be left? X minus 3. So that's the expression that we're looking for to fill in that question mark. So that would be x minus 3. Okay? Now the other question mark. This distance is y. This distance is 1. So the question mark must be, Andy? Say it again? Y minus 1 is correct. So the big distance is y. We take the 1 away, and we're left with y minus 1. Okay? And how long is our radius? 4. So the hypotenuse has to be 4. Okay, so now that we have those lengths measured, everyone used the Pythagorean Theorem to write an equation for that circle. Leg squared plus leg squared equals hypotenuse squared. We have a right triangle right here. Okay, Kate, what equation does the Pythagorean Theorem give us?
X minus 3 squared plus y minus 1 squared equals r squared.
Equals 4 squared. Good. Okay, x minus 3 squared plus y minus 1 squared equals 4 squared. That is the equation of that circle. That equation represents every possible point that we could put on that circle. So we could plug in any x value and find the corresponding y value, or we could plug in any y value and find the corresponding x value, as long as it is a point that's on the circle. Okay, so that's the equation there. And then we can generalize that. For example, 4, if we have the same kind of situation, but our center is at HK, and we draw a circle with a radius r, we could do the same thing. The horizontal distance would be x minus h, just like this one had a horizontal distance of x minus 3. The vertical distance would be y minus k, just like in the previous example it was y minus 1. And so the general equation that we get for any circle with a center at hk and a radius r would be x minus h squared plus y minus k squared equals r squared. And that is the equation we're going to use a lot in writing equations of circles. Again, I'll go to Desmos so you can see what that would look like. So here I'm going to put x minus h squared, y minus k squared equals r squared. And it gives me sliders for each one. So for example, if I go to, we had 3, 1 is the point that we did for the last example with a radius of 4. So there's a circle with a center at 3, 1 right there. 3, 1 with a radius of 4. Okay? And as I change h, it slides the circle left and right. If I make h 0, it puts it right on the y-axis because it has an x-coordinate of 0. If I make h negative, it moves in the negative direction. Okay? So that equation will give us any circle in the xy plane, where h and k gives us the center and r gives us the radius. Okay? So now we should be able to do problems like this, write the equation of each circle given the center and the radius. So using that equation, which was x minus h squared plus y minus k squared equals r squared. Our center is at negative 4, 5, so we're going to fill in negative 4 for h and 5 for k, and r equals 6. So it's going to be x minus negative 4 squared, y minus 5 squared equals 6 squared. And so if I simplify inside the x component, that's going to be x plus 5 squared plus y minus 5, or sorry, that was x plus 4 squared, y minus 5 squared equals 36. So that is the equation of the circle with center negative 4, 5 and radius 6. So I want you to notice some patterns. When that's positive 5, this says minus 5. When this is negative 4, it says plus 4. So it's the opposite relationship because all those equations that we derived earlier had x minus h and x minus k. And so we're always subtracting h and k. So when we're subtracting a negative, it turns into a positive. Okay? Go ahead and try B and C in your group. See if you can write the equations of those circles. Okay, Chloe, what did you guys get for example B?
We got x minus 3 squared plus y plus 5 squared equals 9.
Perfect. Just plug in H, K, and R, and you have it. Nice job. Okay, and then Tanvi, how about C?
X plus 5 squared plus y minus 0 squared
Equals what?
the square root of 7 squared.
Okay, and then we'll go ahead and simplify. So this is going to still be x plus 5 squared, but then y minus 0 is just y, so that just stays y squared. And then what's the square root of 7 squared? 7. Square root of 7 squared is 7. Okay, so that is the simplified equation for that one. Any questions on those? So those are similar to the types of problems you'll be doing on the assignment today. You'll be given a center and a radius, and you have to write the equation of the circle. You're also going to be asked to graph some circles. So when I take a look at this one, first thing I want to do is identify where is the center. If I'm going to graph it, I need to know where the center is, and then what's the radius. So Korea, can you tell us what the center is for A?
Is it 4, -2?
Close. Who can help?
-4, 2.
Good. -4, 2. So remember, it's the opposite. because we subtract h and k. So here we're subtracting 2, and here we're actually subtracting -4. So it's -4, 2. So the center is -4, 2. And what is our radius, Melvin?
16.
That's the radius squared is 16. So what?
4.
Yeah, that's right. Radius is 4. Good. And so now we go to -4, 2. So -4, 2 is here, and it's going to go 4 to the right, 4 up, 4 to the left, and 4 down. And so we can sketch that circle. Okay, and since it just touches the y-axis, we say that the circle is tangent to the y-axis. Tangent means it just touches it without crossing it. Okay, so the circle is tangent to the y-axis at 0, 2. Okay, that's the point where it just touches. All right, everyone go ahead and graph example B, please. Caden, what did you get for the center?
0, -1,
And the radius?
3.
Good. So we have a center at 0, -1 down here. And radius 3. So we go 3 to the right, 3 to the left, 3 up, and 3 down. And there's our circle. Okay. Any questions? All right, that's it for today's